So in the last section, we looked at basically just rewriting a couple identities. In this portion, we are going to talk more about the idea of simplifying trig identities. So let's get started. Right now we are focusing on section 5.1 with the fundamental identities. Those identities were the ones that were listed in the chart in the first slideshow that I discussed with you. In Chapter 5, we will be looking at sections 5.1 and 5.2. We will not focus much, if at all, on 5.3, 5.4, 5.5, or 5.6. So in this example, we are trying to take sine theta cotangent theta and the directions say to rewrite it using just sines and cosines. So sine theta already has terms of sine and cosine, so I'm going to keep it that way. But cotangent theta I can rewrite in terms of sine and cosine. And so this is where I'm using my list of identities. Cotangent has two options. I could put it as 1 over tangent, which has nothing in terms of sine and cosine, or I can write it as cosine over sine. So that sounds a lot more useful. And once I put it as cosine over sine, then I can use some algebra information here. If I put my first half of that first sine over 1, I now have a numerator and a denominator that are the same. So sine divided by cosine divided by sine cancels. And I am now down to cosine theta. That is my final answer. I started by rewriting and then I simplified. Cosine theta is the end result. Now, in our second example here, it says again to write in terms of sine and cosine, and so I start by saying that I have sine squared theta outside the parentheses. So I'm thinking that distributing my sine squared theta is probably a good idea. So I'm going to take my sine squared theta cosecant theta minus, and then sine squared theta. Okay, now cosecant theta, I know can be put in terms of sine or cosine. It happens to be 1 over sine. So next line of work here, sine squared theta times 1 over sine theta minus sine squared theta. Oops. Which means that I can take my numerator, my sine squared, put it over 1, and sine squared and plain sine will cancel. So now I have sine theta minus sine squared theta. And I know I have a sine squared, but it doesn't quite fit any of those options that I had, like 1 minus sine squared. So this is probably as far as I can take it, and that's my final answer. Okay, so for this one, it says, again, write in terms of sine and cosine, and I want to take that cotangent. I know I can put that in terms of sine and cosine. Before I do that, I'm going to look at the way that this problem is set up, because I'm taking a fraction, well, I'm taking something plus something over a blah, and because I have the piece in the denominator is all stuck together, I am able to split up what I have in the numerator. So let me show you why this works. If I were to take 1 plus 3 divided by 2, now we know in our heads 1 plus 3 is 4, and 4 divided by 2 gives us 2. But I could take this, showing you what I'm doing here. I'm taking 1/2 plus 3 halves. And I hope you'll agree with me that 1/2 plus 1 and 1/2, that's 3 halves, is the same thing as 2, which is what we also got by originally taking the 1 plus 3 gives us 4 over 2, and 4 over 2 is 2. So I'm trying to show you why I'm allowed to split that numerator by the 2 in the denominator, because I would really like to do that with my cotangent here. Make this 1 over cotangent. And why is that so nice? Well, let's think about what we have here. Cotangent over cotangent is called 1. And 1 over cotangent, I'm pretty sure that's called tangent. So now I can take plain tangent and write that as sine theta over cosine theta plus 1. If you don't like what I did there, I have option number 2. Excuse me, which is to take 1 plus cotangent and turn it into 1 plus, let's see, cotangent is also known as cosine over sine. And divide it by cosine over sine. And that means we have a big fraction being divided by something. So I could take my big fraction, all this stuff up here, and multiply it by the reciprocal of this guy, which is exactly what's going to happen in this line of work here. And here goes. I'm going to multiply by the reciprocal, which my reciprocal would give us a sine theta over a cosine theta. And so that has to be distributed to everything inside. So 1 times would give me sine theta over cosine theta plus, okay, now let's see what happens. Cosine theta sine theta over sine theta cosine theta. And now I have a bunch of stuff that's going to cancel because cosine divided by cosine and sine divided by sine sure looks like a 1. And and sine theta over cosine theta gives me the exact same answer as what I got using my much simpler option from the first question. Okay, so in this question, we are asked to simplify cosine squared theta times 1 plus tangent squared theta. So I have two choices here. I could distribute my cosine squared theta, but I'm starting to see things that have squareds in them. And so I'm going to go back to my list of squareds. And I know that cosine squared, I could replace that with 1 minus sine squared. But if I put in 1 minus sine squared, that's starting to make my statement longer. And simplify means make it smaller. So I am not replacing my cosine squared. I'm going to keep that. However, 1 plus tangent squared is also on my list of Pythagorean identities. And it equals something smaller than what I started with. 1 plus tangent squared is secant squared. And so I am going to replace 1 plus tangent squared with secant squared. And then I'm going to multiply by cosine squared. And now I'm going to see if I can put anything in terms of sine and cosine. For instance, my cosine squared is in terms of sine and cosine. And secant happens to be 1 over cosine squared theta. So a little more algebra here. Put my cosine squared over 1, so I know what's in the numerator and the denominator. My cosine squareds cancel. 1 over 1 leaves me with 1. In section 5.1, we want to take those trig identities that we had involving sine, cosine, tangent, secant, cosecant, cotangent, and take a trig expression that starts out long, simplify it to get a much smaller final statement. And we are going to practice this for the next several days.